all of you. In this particular module of kinematics, we'll be coming with some small relations that we do require, especially when we try to solve some problems. We come across certain terms which are called time of ascent, time of descent, time of flight, and etc., etc., etc. Remember, kinematics can be broadly divided into two. Number one, if the motion is confined to a straight line, it's called one-dimensional motion. But if the motion is not along a straight line, but on a plane, then that's called a two-dimensional motion. Let me tell you why it's called one-dimensional motion. Imagine it's moving along x-axis. Then x-coordinate of that particle which is moving is a function of time, which means it depends on time. So, at different locations, it is available at different instants of time. So, x is a function of time, or y is a function of time, or z is a function of time. That's all regarding one-dimensional motion. Shall I tell you that there is a funny thing in one-dimensional motion? And that funny thing is, that's confined only to one-dimensional motion anyway. That if imagine that there is a particle which is in motion, so let me try to call it motion, which means the velocity is in that direction. And imagine that the acceleration is in this direction, which means the acceleration is in the opposite direction. Then I will find that this velocity diminishes with respect to time. The value of the velocity diminishes. The best example is throw a stone vertically up. Motion is upward, but the acceleration of the stone, called acceleration due to the gravity, that is down. So acceleration is down, but the motion is up. Both are opposite. So what do you find the velocity? Is it increasing or decreasing? 100% decreasing. So that's what I told you here. And the logic is the same, please. I can get the same logic. Imagine a particle is traveling like this, which means the motion is to the left, whereas the acceleration is towards the right. So then I find again that the value of this velocity reduces. So there is a clear thumb rule that if V and A are in opposite direction, no matter whether V is to the right and A is to the left, or vice versa, the value of V has to diminish with respect to time. That's a logic that we came to know. Now you cut a line here and try to write down here that this is supposed to be the velocity and this is supposed to be the acceleration. You are able to see that the acceleration is in the same direction as velocity. Now you will find that the value of this V will increase with time. The classic example is, imagine a mango is falling down, motion is down, acceleration also is down. So you will find that the value of the velocity with time is increasing because the mango falls down with increasing speed. Same logic is applied here also, that this is supposed to be the velocity and this is supposed to be the direction of acceleration, and you will find that the value of the velocity has to increase. So these two belong to one category and these two belong to one category, and that is applied only to one-dimensional motion. And this is not applicable to two-dimensional motion, but this is confined to one-dimensional motion.